So what I've got here is just an assembly that I put together. It's just 2 plates, nothing too fancy. I have a distance mate in there that was for position only of 185, just to make sure it's in the right spot. So what I'm going to do is add in a new part. So this time it's going to be in the context of the assembly only. And I'm going to create that starting with a sketch on the front plane. So what I'm going to do is create a sweep. So along what path am I going to create my sweep? So just like any other time, that's what I have to do. 2 sketches, a path, and a profile. This time I'm going to use it a little differently, but that's what I'm going to start with. So for my path, it's going to be a simple line that goes from the origin all the way through the top hole. So I'll go ahead and create that vertical line. Quick relation in here. And then that's all I need for my path. So that's done, exit sketch. I'm going to do another sketch for my profile, again on the front plane, this time of the part, which is the same thing as the assembly. And the diameter of this guy is going to be 10, and it's going to be spaced 25 from the center of the circle to the origin. So that's the radius of the spring, or what will be the radius of the spring. One quick relation, a horizontal, and now that one's fully defined. So you're used to a sweep, profile, and path. What I'm going to do a little bit differently this time, well, I don't really need that right now, actually. So what I could do is a helix, and you're used to perhaps creating geometry like this using a helix, but I'm just going to use a straight line. So under my sweep, grab my profile, grab my path, and then I'm going to go to my options and see what's available there. So orientation / twist type. And if I choose one of the last 2 options here, twist along path or twist with controls, I can do a little bit different definition. So define by either degrees, I can also do radians or number of turns, which I like that one, so I'll try that one. Turns. And I'm going to choose 10 turns in this case. If I hit enter one time, it should show me a preview here. Okay, so you can see it creates a spring-like effect. So it's not maybe specific up to a standard, but you can get pretty darn close. Change it maybe to 15 if I want it a little bit more dense. But just so that you can see what's happening here, I'm going to leave it at 10 for now. I have a little bit more cleaning up to do, so I'm going to go into another sketch to get rid of kind of the overflow on top of the plate there. So I'll use my convert entities and then an extruded cut through all. Do that again on the bottom, so front plane, sketch, convert entities, and extruded cut through all. Alright, so that got rid of some of the garbage, the extra on either side of those plates. Now I can exit the part. So now I have an in-context part, which is fine, and I'm going to use that in my assembly. And since it references those plates, that was very important that it references those plates. That's the only way that the spring knows its height, because the path is dictated by the distance between the 2 plates. Rather than creating manual motion here, I'm going to use a motor. So there's either a rotary motor or you could do a linear motor. I'm going to choose linear in this case. First pick is where am I going to place that motor. So I'll choose this center because I want it to be centered on that plate. I'm going to flip the direction, and just to give it a little bit extra definition, rather than an edge, I'm going to choose that entire face. So that's where the motor is sitting. Now I have to define how that motor is going to control the movement of this assembly. So I have the option of constant speed, defined by millimeters per hour. I can do a distance, I can make it oscillating, I can do different segments defined, a data path, or even define an expression. So you can load it in from other files as well, but for here I'm going to use oscillating. My displacement is going to be 40 millimeters. I'm going to go 0.5 on my hertz, and then my phase shift, I'm going to go at 90. So that's the offset from 0. And if you click on this chart here, it'll show you, on my other screen, there we go. It'll show you your displacement versus time in this case. So kind of what your sine curve would look like. So that's a nice piece of data to be at your fingertips. You can see the 0.5, so from the different points on here, it starts at 90 rather than 0, that kind of thing. So, okay, so green check. And as soon as I click the green check, watch my timeline. So my linear motor has been added, and also some motion automatically was added. So I'll go ahead and hit calculate. So anytime you have a motor or anything like that, I like to hit calculate just so that it really goes through and solves that number. So pay attention to this number right over here as the different positions happen. And that's just a reference dimension. And the first time through, it's usually a little bit slow because it's still recording everything. It could be a little jerky, but as soon as you play it the first time, it gets a little bit better. And notice that the spring's length is changing based on the position of those plates. So here you can see a little bit better the oscillation and its effect on that spring. So that's pretty cool. In real life though, the diameter, the radius, is going to be probably different if it's expanded versus contracted. So I'm going to edit this part once more, and I'm going to look at my feature dimensions. So right click on the annotations folder and show the feature dimensions. I do want to make sure Instant 3D is turned off for this. I'm going to double click on this 25, which is the radius of the spring, and add an equation. Oh, on my other screen again. Here we go. Okay, so using that 25, which is, as I said, the radius of the spring, that is what's going to be control. And I'm just going to throw a quick equation in here. Whoops. A quick equation that will eventually control the size of this, so that as it gets longer and shorter, it also increases and decreases in the radius. So I'll just throw that equation in here, and I'm going to choose that reference dimension as part of this so it can be included in the expression. Okay, so there it is. And now you can see that my 25 is controlled by an equation. I'm going to exit my part. Now let's take a look at what effect that has on my motion study. So I'll calculate it again, and you can notice not only is the height number changing, but so is that radius number. So as I said at the very, very beginning, this is the question that we get fairly often. How do I animate, make it look at least like a spring is expanding and collapsing? So this is a really good method. And using the twist method rather than using a helix obviously is going to save you quite a bit of time on performance. So quite a bit of rebuild time. That's what I was looking for. Rebuild time on your SOLIDWORKS model.